Welcome to Aryabhat Center for Theoretical Physics. This is the video based on this lecture series Mechanics 1, and this lecture series is full course on classical mechanics. In the last lecture I have explained what you call law of gravitation, and this lecture is all about geosynchronous satellite. What is geosynchronous satellite? Geosynchronous satellites are those satellites which are in the stationary orbit relative to the Earth. It means if this Earth is rotating with certain angular velocity, this satellite is also rotating with same velocity. It means this satellite is static with respect to the Earth. So this satellite we call geosynchronous satellite. Now we are going to calculate the height of the geosynchronous satellite from the Earth surface. What is the height of the geosynchronous satellite? Assume that mass of the satellite is m, mass of the Earth is me, and radius of the satellite is r from the center of the Earth. Now we know that it is what we call revolving with respect to the Earth frame. So mv square there will be a centripetal force, and this will be balanced by the gravitational attraction between these two. So Gmem divided by r square equal to mv square by r. So centripetal force will be in equilibrium with gravitational force, and also it is equal to m omega square r. Omega is v by r, omega is angular velocity, and when we solve this for the r, we will get Gme divided by omega square to the power 1 by 3. So this is the what you call this is the radius of the satellite from the Earth's center, and when we plug all the value of this, t is 24 hours, it means 86400 second, g is this, and me mass of the Earth is 5.97 into 10 to the power 24 kg, value of g gravitational constant, and r is 4.22. When we plug all this, we get 4.22 into 10 to the power 7. This is the radius of the stationary satellite from the Earth's origin. Now we have to subtract the radius of the Earth. So radius of the Earth, it means h equal to r r minus re. R is 4.22 into 10 to the power 7, and radius of the Earth is 6.37 into 10 to the power 6, and we will get h is roughly 35800 kilometer. This is the what you call height of the geosynchronous satellite from the Earth surface. Now we will use this one to calculate the velocity of this geosynchronous satellite. So we will cancel this m, and we are left with, and this r will be cancel it out, and we are left with root gme by r. This is the velocity of any satellite revolving around the Earth. And remember, there is no mass of the satellite in this equation. It means the velocity of any satellite which is revolving around the Earth does not depend on the mass of the satellite. It means suppose there is a small satellite and there is a big satellite. Both will revolve with same velocity around the Earth, because this velocity of the any satellite doesn't depend on the mass of the any satellite. So this is the velocity of the geosynchronous satellite and height from the surface of the Earth. This is the problem to how to calculate force of gravitation between any two mass. There is mass m1 and m2 which has 50 kg each. Each mass has 50 kg and distance between these two masses are 1.5 meter. We have to calculate the gravitational force between two. We know that gravitational force is g m1 m2 divided by r square. G is this one 6.67 10 to the power minus 11 Newton meter square per kg square. M1 M2 we know 50 kg each, R we know 1.5 meter, and we will roughly get 7.4 into 10 to the power 8 Newton. This is the gravitational force between these two masses. So this is how we can calculate gravitational force between two objects. We simply plug the value of the mass and distance and we will get gravitational force.